Welcome to the deep dive, everybody. Looks like we've got some really interesting research to dive into today. Stuff about how karst geology, those crazy cave landscapes, can really mess with flood predictions.
Yeah, it's definitely a tricky one.
But that's why we're here, right? To break it all down.
Absolutely.
So we've got a bunch of research all about the Lijiang River Basin over in China. Beautiful spot, by the way, if you ever get the chance.
Oh, yeah, it's stunning. The karst formations there, like something out of a movie.
Totally.
Yeah.
But it's also an important region, economically speaking. So getting those flood predictions right is pretty crucial, wouldn't you say?
Absolutely critical. And that's where things get tricky with karst. You see, it's all about how water flows, or doesn't flow, I should say, in predictable ways.
Right, because instead of rivers and streams on the surface, you've got these underground networks, like a maze of caves and tunnels.
Exactly. So those traditional flood prediction models, they kind of fall apart in these areas.
So what did the researchers try first? Did they just throw their hands up in the air?
Well, at first they used something called the HEC-HMS model. Pretty standard tool for flood prediction. But those early simulations, way off the mark, like way off.
How off were we talking?
In one case, the model predicted a peak flow that was 10 times lower than what actually happened.
Whoa, that's not just a little bit off, that's a whole other ballpark. So what were they missing?
They were missing the key ingredient, soil moisture. Turns out the soil moisture in these karst systems acts like a giant gauge for how much water the whole system can actually absorb.
Okay, so how does that work? Does wetter soil mean more flooding?
Not quite. Think of the whole karst underground like a giant sponge, right? When it's dry, that sponge is empty and it can soak up tons of rainwater, meaning less runoff, smaller floods. But when it's wet, well, that sponge is already full, so any extra rain just runs right off, leading to these big, sudden floods.
So it's all about how much space is left in that karst reservoir. Makes sense. Researchers even came up with a fancy name for it, the available reservoir capacity of karst, or ARCK. So does this mean if we keep an eye on soil moisture, we can actually get a handle on those flood predictions in karst regions?
That's the idea. Sounds simple, but figuring out that connection between soil moisture and flood risk wasn't exactly a walk in the park.
What did they do? Did they just go out and, stick their fingers in the dirt?
They collected over a year and a half of daily soil moisture readings at different depths, and they combined that with rainfall and river flow data from the Lijiang River Basin. Lots of data.
I bet. But how do you make sense of all that information?
Well, that's where the real magic comes in. They used an artificial neural network to analyze the data, specifically a type called an LSTM network.
Artificial neural networks. Sounds pretty high-tech. Are we talking like robot brains here?
In a way, yeah. These networks are basically computer systems that learn from data, kind of like how our brains learn. And LSTMs are particularly good at understanding data that changes over time, which is perfect for this kind of research.
Okay, I'm starting to see how this all fits together. So the computer can, learn how the whole karst system changes over time and then use that to predict floods.
Exactly. It can actually see the patterns, the relationships between soil moisture, rainfall, and flood size, even when those patterns are hidden beneath the surface.
Okay, now you've got me really intrigued. Can you give us some concrete examples of what the computer discovered, like how much of an impact does this soil moisture actually have?
Let's compare two different rainfall events, shall we? Just to illustrate. First, picture a relatively small rainfall, let's say about 21 millimeters per day, spread out over 4 days. But this happens during the wet season when that karst sponge, remember, is already pretty full.
Oh boy, I can already see where this is going.
Yeah, even that small amount of rain caused the river flow to jump up dramatically, between 10 and 20 times higher than normal.
Wow. So even a little rain can cause a big problem if the karst is saturated.
Exactly. Now contrast that with a much heavier rainfall, like 87 millimeters per day for 2 days straight. But this time, it happens at the end of the dry season when the karst is like that empty sponge, ready to soak it all up.
So the karst could actually handle that heavy rain.
Pretty much. The heavier rainfall only caused a tiny increase in river flow, barely noticeable. That's the power of understanding how much water that karst can absorb.
That's incredible. So just by knowing how full the karst is, we can get a much better idea of the real flood risk. This is groundbreaking stuff. But hold on, how do they actually use this new ARCK knowledge to improve the flood predictions? Do they just look at the soil and make a guess?
Not quite. They took all that soil moisture data and the ARCK calculations and they plugged it all into that HEC-HMS model. You know, the one that's giving them all the wrong answers before. Basically, they gave the model a major upgrade, teaching it to speak the language of the karst.
So they taught the computer to think like a karst system. That's pretty clever. And how much did this actually improve the predictions?
They saw a significant improvement in the model's accuracy, on average about 16%.
That's a huge jump. But before we move on, I'm really curious to know more about how this LSTM network actually works. How does it actually learn about the karst system? What makes it so good at seeing those complex patterns?
Excellent question. And that's a perfect segue into our next segment. Welcome back. Now, before we get too deep into how that LSTM network actually works, let's talk about something else that's been on my mind. We've been focusing on the Lijiang River Basin, but do you think these findings apply to, all karst areas?
That's a good question. I mean, every karst landscape is unique, right?
True, but the basic process of how karst forms, that dissolving of rocks, that's happening everywhere. Globally, we're talking about 20% of the Earth's land surface.
Wow, that's a lot of karst. And a lot of potential flood zones.
Exactly, and a lot of places struggling with those same flood prediction problems.
So this research in China, could it be like a blueprint for other regions?
It could be a really good starting point. Researchers can definitely adapt these techniques, taking into account the specific features of each karst system.
So not a one-size-fits-all solution, but a solid framework.
Exactly. Okay, now back to that artificial neural network. You mentioned it's a type of AI. Can you explain how it actually learns about the karst system?
To be honest, I'm still a bit fuzzy on that. What is this LSTM network thing anyway?
Imagine a super sophisticated pattern recognition machine. It's got all these interconnected nodes like neurons in our brains.
Okay, so it's mimicking how our brains work.
Kinda, yeah. These nodes process information they learn from data, but LSTMs have this special ability. They can actually remember information from previous steps.
So it's not just looking at each piece of data separately, it's connecting the dots.
You got it. It's like the network is learning the karst's history, understanding how it's behaved in the past to predict what it'll do in the future.
So it's like teaching the computer to speak karst, so to speak.
Exactly. And by incorporating all this learning into that HEC-HMS model, researchers were able to get those predictions much closer to reality.
So it's all about giving the model the context it needs. Fascinating. Did they find anything else interesting about the karst system itself?
It's really cool. They looked at how soil moisture responds to rainfall at different depths. They were measuring it at 10 centimeters, 40 centimeters, all the way down to 200 centimeters.
Wow, that's pretty deep.
Yeah.
Did they find differences in those layers?
Big time. The deeper you go, the less sensitive the soil moisture is to rainfall. Those lower layers are less affected by individual rain events.
So it takes more rain to make a difference down there. Does that mean we can just ignore those deeper layers when we're trying to predict floods?
Not so fast. Those surface layers, they definitely give you the most immediate response, right? That's key for short-term flood risk. But those deeper layers, they contribute to the overall capacity of the whole system. They're storing water over longer periods, influencing the overall behavior of the karst.
It's like the karst has a short-term memory and a long-term memory.
Exactly. You need to understand both to really get a grasp on flood risk.
So it's not just about how much rain falls. It's about how the karst responds over time, both in the short term and the long term.
Precisely.
This research is really eye-opening. But like any study, I'm guessing there are limitations. Anything we should keep in mind when we're thinking about these findings?
You're right. It's important to remember that this was all done in one specific karst region, the Lijiang River Basin.
Right, so we can't just assume these exact findings apply everywhere.
Exactly. The type of rocks, the structure of that underground network, even the plants and trees, those can all change how a karst system behaves. We need more research in other areas to really confirm all of this.
So there's still more to learn, which is exciting, right? It means there's still so much to discover about these hidden worlds beneath our feet.
Absolutely.
This has been a truly fascinating deep dive. We've gone from soil moisture to artificial intelligence, all to understand how these karst systems work and why predicting floods in these areas is such a challenge. But we're not done yet. There's another big piece of this puzzle we need to explore. The human element. How do our actions as humans affect these delicate landscapes? And how does that influence flood risk?
Yeah, that's a crucial part of the story.
So join us for the final part of our deep dive as we delve into the human impact on karst hydrology. It's going to be a thought-provoking one. All right, so we're back for the final part of our deep dive into the world of karst. And we've talked a lot about the natural side of things, but we can't ignore the human element, can we?
Definitely not. I mean, those natural karst landscapes definitely play a big part, but human activity can really tip the scales when it comes to flood risk.
Yeah, we've learned how that whole soil moisture thing works, how the karst acts like a sponge soaking up the rain. But how do we mess that up?
Well, one of the biggest things is urbanization, all that development.
Hmm.
We pave over huge areas, creating all these surfaces that water can't penetrate.
So instead of soaking into that karst sponge, it just runs off.
Exactly. And you get more runoff, faster runoff, and that can lead to more frequent flooding, more intense floods too, especially in karst areas where that underground drainage is already so unpredictable.
It's like we're messing with the natural system that's supposed to control the water flow.
Yeah, you could say that. And it's not just the amount of pavement, it's also how we manage that stormwater runoff. You know those traditional stormwater systems? They're designed to get rid of water quickly, but that can actually backfire in karst.
Really? I would think getting rid of the water fast would be a good thing.
You'd think so, right? But those systems can actually concentrate all that runoff, channel it straight into rivers and streams, and overload them.
So instead of letting the karst slowly absorb the water, we're just dumping it all at once.
Exactly. And you get these flash floods, which karst regions are really vulnerable to.
So what can we do about it? Are we just stuck making things worse as we develop these areas?
Not necessarily. We can design and manage our urban areas in ways that actually work with the karst, not against it. The key is to slow the water down, let it infiltrate more naturally.
Kind of like going back to nature's way of doing things.
Yeah, exactly. And that's where green infrastructure comes in. Things like rain gardens, permeable pavements, constructed wetlands, they all help reduce that runoff.
By mimicking what the karst already does naturally.
Right. They give the water a chance to soak in instead of just rushing away. And that helps to recharge that karst sponge and reduce the risk of those big floods.
It's pretty cool how we can use those nature-based solutions to actually help the karst to do its job.
Yeah, it's all about working with nature, not against it. And it's not just about big projects. Individuals can make a difference too. Planting trees, putting in rain gardens, even using permeable paving for driveways, it all helps.
So we can all play a part in protecting these karst areas.
Absolutely. We all need to work together, individuals, communities, governments, everyone, to find solutions that actually work for the long term.
It's a good reminder that we're all connected to these landscapes, even if we don't always realize it.
Exactly. And our actions have consequences, big or small.
Well, this has been a truly fascinating journey, hasn't it? We've uncovered a whole hidden world beneath our feet, learned about how soil moisture and AI can help us predict floods, and how we can all do our part to protect these incredible karst landscapes.
It's been a real eye-opener for me, too.
Thanks for joining us for this deep dive into the world of karsts and flood prediction. We'll see you next time.